Hi everyone. Well, we're almost done. We just have to get through the final exam. And so these are the practice problems. You can find these in the same packet as all the other practice tests. So this is after test 4, and these are the problems you should have gone through. And I'd say at least half of them. And I'm going to try to get through half of them as well. The answers are in the back, so you have the answers for all of them. And most of those answers are correct. There could be a few typos every now and again, but not usually. All right, so I'm just going to start at number 1 and proceed from there. So number 1, solve by the method of addition or elimination. Some of you may have also looked at the method of substitution, but let's follow the directions and use the method of elimination here. So for part A, we have 4x plus 5y equals 9, and 2x plus 3y equals 6, right? So this goes way back, right? This is the very first thing we did this semester, is solve a system of equations, right? All right. So what do we want to do? We want to eliminate either x, right, or y. The choice is yours, right? I would eliminate x here, and the reason is because I'm noticing that, okay, the first coefficient here is 4, the second one is 2. Well, 2 times 2 is 4, so all I need to do to match the 4 up here is to multiply the bottom equation by 2. Now that'll make it 4x, but we want to eliminate the x's, so we want it to be negative 4x, right, to cancel the positive 4x up here. So I'm going to multiply both sides by negative 2. Oops. Right? So the first equation is still 4x plus 5y equals 9. We can leave that one alone. And for the bottom equation, we're going to have negative 4x, and then negative 2 times 3, right, is negative 6, so negative 6y. And that's going to equal 6 times negative 2, right, negative 12. Remember, you have to multiply both sides by negative 2, not just the terms on the left, but the 6 on the right as well. All right, now all we need to do, right, because it's the method of addition, we're going to add the two equations. 4x plus negative 4x is 0x. 5y plus negative 6y is negative 1y. And 9 plus negative 12, or 9 minus 12, is negative 3. So we have negative 1y equals negative 3. Just divide by the negative, or the negative 1, rather. And so that cancels the negative 1, and we're left with y is equal to negative 3 divided by negative 1 is just positive 3. Right? So y equals 3. But remember, we're not done yet, right? A solution is not just a number here. It's a pair of numbers, right? Your solution is an ordered pair. It's an x and a y. So far, we only found the y. Y is 3. Now we have to go back and find x. And we can do that just by replacing y with 3 in either equation, right? We can use the top one or the bottom one. I'll just do the top one. So 4 times x plus 5 times y, but remember we know now y is 3, and that equals 9. So 4x plus 5 times 3 is 15, and that equals 9. Now we just subtract the 15 from both sides, leaving you with 4x on the left and 9 minus 15 on the right. 9 minus 15 is negative 6. I think that's right, yeah. And now just divide by the 4. So that cancels the 4. X is going to be negative 6 over 4, which reduces to negative 3 over 2. Okay, so that's x. This is y. Now we have our solution, right? The solution is negative 3 over 2, comma, 3. So that's how the answer appears in the solution, and that's how you should write your answer, right? Don't just write the x's and the y's here. Write it all as an ordered pair. That's the solution. Okay, so that's part A. I'll do part B as well. So part B is, just going to copy down the equations. It's 3x minus 9y equals 4, and 4x minus 12y equals 5. Okay, so again, we want to use the method of elimination. So what do we want to eliminate? X or y? Again, it doesn't matter, right? We eliminated x in the first problem in part A. So, well, why don't we do it again in part B, right? So let's eliminate x again. And why am I choosing x? Because, well, the coefficients for y are just bigger numbers and they're negative, so that does not look as pleasant. Okay, so how do we eliminate x, right? So here it might not be as obvious, because if you're thinking what number times, 3 is equal to 4, yeah, you'd have to use a fraction there. You would essentially have to use 4 over 3. Okay, so there's a better way to do this, and that way is just to multiply the first equation by the second number, the second coefficient, which is right this 4 here. So just use that as the multiplier for the first equation. And then for the bottom equation, use the coefficient from the first equation, right? So just switch them, right? Multiply both sides here by 3. Right, now, here they're both positive. Remember, we want one to be negative, so it doesn't matter which one. Let's make the bottom one negative. Right? You could have made the top one negative as well, but not both, because we don't want them both to be negative. We want one to be positive and one to be negative. Right, so the first equation becomes 12x minus 36y equals 16. The bottom equation becomes negative 12x plus 36y is equal to negative 15. Now, when you add the equations, 12x minus 12x is 0x. That was by design. And now we have negative 36y plus 36y is 0y. And that's going to equal 16 plus negative 15. Well, 16 minus 15 is 1. So the left side, 0 plus 0 is just 0. The right side is 1. So 0 equals 1. What does that mean? Right, well, that's nonsense, right? 0 is not the same number as 1. These are not equal. 0 does not equal 1. Right? In any respectable system of numbers, 0 and 1 are two different numbers. So what does that tell you about the original system here? It tells you that there is no value of x that will make this work. That is, there is no solution to this system. Right? So that's the answer here, no solution. Right? You can stop right there. So when you get two numbers that are not equal, right, and it doesn't have to be 0 and 1. It could be negative 8 and, 17. These numbers are not equal. That also tells you that there would be no solution to that problem. Right? All right, last one. And I guess we'll do part C because, well, it looks difficult, right, because it has fractions in it. So this is number 1C. Again, we want to solve the system of equations 1 over 12 times x minus 3 over 4 times y. That's going to equal 1. And the second equation is 2 over 3 times x plus 1 over 2 times y is equal to negative 5. Okay, so yeah, nobody likes fractions, but no, sometimes you just have to deal with fractions. On the other hand, since these are equations, we don't have to deal with fractions if you don't want to. And I don't want to, right? I want to get rid of the fractions. So by now you should know how to do that, right? You multiply both sides by the least common denominator. So for The first equation, we have a denominator of 12 and 4. What is the lowest common denominator? The least common denominator is 12. If you're thinking 4, you're probably doing greatest common factor, not least common denominator, right? So if I multiply both of these sides of the equation by 12, you know what, let me do it down here. I'm going to keep the original, keep the original set of equations. I just have to copy them down again. And then we'll just multiply by 12. Again, both sides. Right? And think of it as 12 over 1, right? It's not 12 over 12. Right? We're not adding or subtracting fractions here. Right? So distributing the 12, we're going to get 12 over 12 times x minus 12 times 3 over 4 times y is equal to 1 times 12, which is 12. Okay, 12 divided by 12 is 1, so this is just 1x. The 1 is optional, right? I'll just write it as x. Minus, so you could do 12 times 3 is 36, and 36 divided by 4 is 9. Or you can do 12 divided by 4 is 3, and 3 times 3 is 9. Either way, you get 9y. Well, negative 9y, because it's a minus sign, right? Equals 12. Okay, so that's the first equation here, right? The first equation, I'll just copy it down. X minus 9y equals 12 without the horrendous fractions, right? Now we don't have to deal with fractions anymore. On the other hand, there's still the second equation we have to deal with, and that still has fractions. So let me, again, copy that down here. 2/3 x plus 1/2 y equals negative 5. So what's the least common denominator out of the 3 and the 2? Okay, it's not 2, it's not 3, but if we multiply 3 times 2, we get 6. So in this case, 6 is the least common denominator. 6 over 1. So multiply both sides by 6, and we're going to get 12 over 3, which is 4 times x, plus 6 over 2 is 3. So 3y. And that's going to equal negative 5 times 6, which is negative 30. Okay, so that's the second equation, the bottom equation. 4x plus 3y equals negative 30. Okay, so yeah, so I simply I haven't really solved anything yet. All I did was rewrite these two equations with fractions as these two equations without fractions. Right, now we just do the same thing as in the first two problems, right? We eliminate either x or y. And since we've eliminated x in the first two in the first two sections, A and B, the first two problems, right? Let's eliminate y. I mean, you might think x is easier, and it is. Just multiply by negative 4, and that would eliminate x. But suppose we want to eliminate y. So if we want to get rid of negative 9, and we only have 3, well, I have to multiply by 3 to get 9, right? So I'm going to leave the first equation alone, x minus 9y equals 12, and I'm going to multiply the second equation. In order to cancel the negative 9, I'm going to make this a positive 9y. And I do that by multiplying by 3. Okay, so 3 times 4x is 12x, and 3y times 3 is 9y, and negative 30 times 3 is negative 90. So when we add everything up, we get 1x plus 12x is 13x, negative 9y plus 9y is 0y, and 12 plus negative 90 is negative 78. Yep, I think so. So having eliminated the y now, 0y is 0, we just divide both sides by the 13. Okay, so negative 78 divided by 13 is get negative 6. Right. All right, that's x. And we're not done because remember, a solution is not just a single number. It's a pair of numbers, right? It's an x and a y. We have x, negative 6. Now we have to find y, right? And you do that by plugging in the negative 6 for x. You could do that in the original equations up here, but now you're dealing with fractions again. So why don't we just replace x with negative 6 in the first equation up here, right? You could do the bottom equation before or after you multiplied by 3. All right, so instead of x minus 9y equals 12, we have negative 6 minus 9y equals 12. So I have to add 6 to both sides. So negative 6 plus 6 is 0. Negative 9y equals 12 plus 6 is 18. So if negative 9 times y is equal to 18, when you divide by negative 9, you get negative 2. So x is negative 6 and y is negative 2. And there's our solution, right? In the upper right corner, negative 6, negative 2. All right, and part D is similar to, I'd say, part A or B. You don't have fractions there. So let's move on to number 2. And this is kind of a hard one, right? This is a word problem, an application of systems of equations. So it says the sum of two numbers is 33, and the sum of the squares of these numbers is 557. Find the two numbers, right? So we're looking for two numbers. Let's just give those names. Say x and y. So let x and y be the two numbers. Right. And you don't have to use x and y. Those are just the conventional letters that represent numbers. Those are the variables, right? You can use a and b. You can use w and k. Just any two numbers, right? Any two letters. All right. So what do we know about these two numbers? Well, we know that the sum of these two numbers is 33. What does that mean? Sum means adding, right? So when you add the two numbers, x plus y, you should get 33. Right? And there's one equation, but that's not enough, right? Because there's a lot of numbers that add up to 33. But we also know that the sum of the squares of these numbers is 557. So what do we mean by the square of the number? Just multiply by itself, right? X squared is the square of x, and y squared is the square of y. The sum of those two numbers is 557. Okay, so that's our system of equations. What's different about this is the x squared. We haven't seen that, right? Or the y squared. So here we're not going to be able to use the method of addition. It's just not going to work very well. We need to use substitution here. So let me remind you how that works. All I'm going to do is take the first equation and solve for, it doesn't matter, either x or y. So right, if I have x plus 3y equals 33, and if I want to solve for y, I just subtract the x from both sides. So y is really just 33 minus x. Okay, so now that I know what y is in terms of x, I can replace this y in the second equation with 33 minus x. So let's do that. We still have x squared plus y squared equals 557. But y is now 33 minus x. Right. So what do I do now? I just multiply this out, right? I get x squared plus, be careful, right? This is not 33 squared minus x squared. It's a very common mistake. But remember what 33 minus x squared is. It's 33 minus x times 33 minus x. So yep, you have to FOIL that, right? Multiply it out. So first, 33 times 33 is 1089. And then minus 33x is minus 66x. And then negative x times negative x is positive x squared. Okay. So you see what we get here, we get a quadratic equation, right? X squared plus x squared is 2x squared minus 66x plus 1089 equals 557. So to put it in standard form, I'm going to subtract the 557 from both sides, right? So that gives you 0 on the right. And on the left, it's going to give me 2x squared minus 66x plus 532. Okay, so this is a quadratic equation. Now you have a lot of different ways of solving it. Of course, you could use the quadratic formula. You could complete the square, or you could try to factor. So I'm going to try to factor. In fact, we could just factor out a 2 here. That's not hard. And then 532 divided by 2 is 266. Oops, sorry, 266. And that equals 0. So the 2 here doesn't matter. I can divide both sides by 2. And now I have this quadratic equation. So, oh, running out of space. So again, you could just use the quadratic formula. I'm going to do this by factoring, right? I'm going to, hang on. Why did I put x cubed here? It's not x cubed, right? It's x squared. So that was probably the first of many mistakes I'll make here. So, okay, x squared, that's a 2, not a 3. All right, so what two numbers multiply to 266 and add to negative 33? All right, so this is gonna take a while. So I'll let you write out all the list of numbers here, right? It's not 1 times 266. It's not 2 times 133. And they have to be negative, right? So negative 2 times negative 133 would work. So they're both negative numbers because they have to add to negative 33. All right, so I hope you got 14 and 19. Right? So that means x minus 14 is 0 or x minus 19 is 0. So x is either 14 or 19. So which is it? Is it 14 or is it 19? Well, remember, we're looking for two numbers, x and y. So if x is 14, y, remember what y is, it's 33 minus x. And 33 minus 14 is, well, 19. On the other hand, if x is 19, then y is 33 minus 19. But that's 14. So it turns out it doesn't matter, right? If x is 14, y is 19. If x is 19, y is 14. The point is the two numbers are 14 and 19. And you can check. 14 plus 19 is 33, so the sum is 33. And if you take 14 squared plus 19 squared, I would use a calculator for that, but you get 557. So it works, right? All right, so that's number 2. All right, number 3, Blake borrowed $19,000 from two banks. One bank charged 2% simple interest, and the other charged 3% simple interest. The total interest charged is $530. Find the amount borrowed from each bank. So what are we looking for? The amount borrowed from each bank. So let x be the amount borrowed from the first bank. This is the bank that charged 2% interest, so the 2% bank, I guess. And let's let y be the amount borrowed, right, the amount of money borrowed from the 3% bank. Hope that's not too sloppy. Okay, so that's what we're looking for, right? We're looking for X and Y. This is the amount of money we're borrowing from each bank. And what do we know about the amount of money? Well, the total is $19,000, right? So whatever we borrowed from the first bank added to whatever we borrowed from the second bank has to add up to $19,000. Okay, so that's the first equation. The second equation has to do with the amount of interest. The total interest that was charged was $530. Okay, so how do we calculate interest? Well, the amount of interest that we're being charged is 2% on X. So 2% as a decimal is 0.02 times X. Right, so this is the amount of interest, I should say. Right, the amount of money that we're being charged in interest. Right, and from the 3% bank as a decimal 0.03 times X. So this is the amount of interest from the 3% bank. The total interest is what you get when you add them up. 0.02x plus 0.03y, and that's going to be $530. Okay, so that's our second equation. Now, if you don't like decimals, it's easy enough. Just multiply by 100, right? 100%, right? And on both sides, that's going to give you, let's see, 2x plus 3y equals 530, and then 2 more zeros, so 53,000, right? And we can leave the first equation alone. X plus y equals 19,000. Okay. So there's our two equations again, this time without decimals, without fractions, right? And we can go back to our usual method of elimination, or the method of addition. If I want to eliminate x, I just need to multiply the first equation by -2, right? Again, on both sides. And if I do that, what do I get? I get -2x. Oh, let me make it a little closer here. -2x plus -2y equals -38,000. Right. Okay, so now if I add that to the second equation, right? Notice this is the second equation, this is the first equation, so they're backwards, but it doesn't matter. When you add them up, you get 0x plus 1y equals, I want to say 15,000. 53 minus 38. Yep, 15,000. So, and that's it. We can divide by 1, but that's still just y equals 15,000. All right, but that's only half the answer, right? This is the amount borrowed from the 3% interest bank. We also need the amount borrowed from the 2% interest bank, right? So we need to find x. But let's just go back to the first equation, right? If x plus y is equal to 19,000, and now we know that x is 15,000, we can find y just by subtracting 15,000 from both sides. Okay, so no surprise, y is just $4,000. Oh, boy, I messed that up, didn't I? Y is 15,000. Y is not 4,000. So I was replacing x with 15,000. My mistake. We should replace y with 15,000. Okay, so it's actually x that's 4,000, right? Subtract 15,000 from both sides. That's a 9. All right. Yep. So we should get x equals $4,000. Okay. So yeah, right. Find the amount borrowed from each bank, right? So we borrowed, or Blake borrowed. Blake is the borrower here. Right, so $4,000 at 2% interest and $19,000 at 3% interest. That should answer the question. And number 4, a boat travels 180 miles downstream in 6 hours. The return trip going upstream, the same distance, took 10 hours. Find the amount of time the boat would require to make the 180-mile trip without a current. Okay, so here we're looking for the amount of time, right, for the trip if there was no current. Okay, so yeah, this one's again a little bit trickier because usually we're not looking for the amount of time, right? We're looking for the speed of the boat without a current. Okay, so let's just say let B be the speed of the boat without a current. And once you know the speed, you know the time, or you can find the time. Right. In fact, before we do anything else, let's remind you, right, the relationship, right? Remember, speed times time is equal to distance, right? So time then, if you divide by speed, is just distance divided by speed. Okay. We know the distance, that's the 180 miles. And we know the speed. Oh, actually, we don't know the speed. That's what we're looking for. That's B, right? And that'll be in miles per hour. So to get the time, we just take 180 divided by B. Okay. But we have to find B. And that's done the usual way, right? So I'll make a little table here, right? We're going downstream and then upstream. We turn around. And again, speed times time equals distance. Right? So let's see. The distance is 180. We can fill that in. Right. Going downstream, the speed of the boat is B plus the speed of the current, which we don't know, so we'll call that C. Okay, so let C be the speed of the current. And the amount of time. Oh, 6 hours. Yeah, 6 hours downstream. And then upstream, because you're going slower, we're going to subtract the speed of the boat minus the speed of the current. And that took 10 hours to go the same distance, 180 miles. So the first equation, right, is just B plus C times 6 equals 180. And the second equation is B minus C times 10 is equal to 180. Right. So those are our two equations. And you could multiply by 6, but because the 6 is on the outside, I would just divide both sides by 6 here. Right? And that cancels the 6. So in this case, B plus C is just equal to 180 divided by 6, I think is 30. Right? And then for the second equation, let's just divide by 10. Right? Because the 10 is on the outside of the parentheses. It's a factor of both. So here we get B minus C is equal to 180 divided by 10, which is 18. Okay. Now we have no trouble at all, right? If we just add the two equations together, we get B plus B is 2B, C minus C is 0, and 30 plus 18 is 48. So if 2 times B is 48, just divide by 2. B has to be 24, right? So remember what B is. It's the speed of the boat, 24 miles per hour, if there was no current. Okay. So now to answer the original question, remember we're looking for the time, 180 divided by B. I'm just going to erase the B, and now we know what B is, right? B is 24. So 180 divided by 24, just put that in my calculator, and I get 7.5 or 7.5 miles per hour. Oh, I'm sorry. That's in hours, 7.5 hours. There we go. Okay, so that's the amount of time it would take for the boat to go 180 miles if there was no current. Okay. You can also write it as a fraction, right? 15 over 2. But it's just 7.5 hours, right? 7 hours, 30 minutes. Okay. So I hope you weren't fooled, because if you think, well, the time going downstream was 6 hours, and the time going upstream was 10 hours, you might think if I add them up, I get 16 hours, and if I take the average, I get 8 hours. But as you can see, that's the wrong answer. So you cannot just average the two times. That does not give you the time without the current. It gives you the wrong answer. Slightly wrong by a half hour. But it's wrong, right? It only takes 7.5 hours to make the trip without the current. Right. Okay, so that's number 4. Okay, so number 5 just deals with the rules for exponents, which I'm hoping you're all familiar with. So I'm going to start with B. I think if you can do B, you can do A. So I think A is the easier one. So for 2B, we want to simplify and then write with positive exponents the expression in parentheses 2p to the 5 r to the negative 4, and then all of that raised to the third power, times, in parentheses, p to the 4, r to the negative 5, all raised to the negative 2 power. So where do we start? First of all, right, we know that when we're multiplying two things and then raising to a power, you can just multiply, right, the two things to that power. So what gets a power of 3 here? Everything inside the parentheses, including the 2, including the p to the 5, and including the r to the negative 4. All of that gets a power of 3. And then what gets a power of the negative 2? Again, everything in the parentheses here. So p to the 4 to the negative 2, and then r to the negative 5 to the negative 2. Okay, so I'm just repeatedly using this rule here, which again, you should know. The next rule we need, well, first of all, 2 to the 3 is just 2 times 2 times 2, so that's just 8. And then what's p to the 5 to the 3? So you should also know if you raise something to a power, say a to the m, and then raise that to another power n, you just multiply the exponents, right? So this is going to be 5 times 3, which is 15. Right? And then r to the negative 4 to the 3 is r to the negative 4 times 3, which is negative 12. P to the 4 to the negative 2, 4 times negative 2 is negative 8. And then r to the negative 5 times negative 2 is positive 10. Okay so far? All right, so now I'm just going to switch the order here. I'm going to put the p's next to each other. So 8p to the 15 times p to the negative 8 times r to the negative 12 times r to the 10. And the rule here, of course, is when you're multiplying two expressions with different exponents, you just add the exponents, right? So in this case, we're going to get 8 times p to the 15 plus negative 8 times r to the negative 12 plus 10. Okay, so 15 minus 8 is 7, so p to the 7, and then negative 12 plus 10 is negative 2, so r to the negative 2. And that's pretty much it, except remember, it says write with positive exponents, and negative 2 is not a positive exponent. So the rule there is when you have something to a negative exponent, it doesn't mean it's negative, it just means you take the reciprocal. So 8p to the 7 is in the numerator, and r to the positive 2 is in the denominator. So that's the answer to, oh, I'm sorry. I don't know why I'm saying it's number 2. This is number 5 here. Number 5, part B. Yeah, 5B. All right, let's go on to 5C, because that one does not look easy. Okay, so we want to simplify this expression here, right? So first thing I would notice is that in the first factor here, we have x to the 5 over x to the negative 3. So if you subtract those exponents, you get 5 minus negative 3, or 5 plus 3 is 8. So 24x to the 8y over 1 squared. And in the second factor, we have x to the negative 4, but that's just 1 over x to the positive 4. And then all that to the power 3. Okay. Okay, so if we just distribute the exponent here, we get 24 squared, x to the 8 squared, times y squared. And then over 1, right, times 1 over, well, it's 1 cubed, right, and this is 1 squared, but that's still just 1. And in the denominator, we get 4 cubed times x to the 4th times y, oops, sorry, x to the 4th cubed times y cubed, right? So this is really just 24 squared times x to the, remember, 8 times 2 is 16 times y squared, divided by 4 cubed times x to the 4 times 3 is 12 times y cubed. Okay. Now, 24 squared, 24 times 24, probably just use a calculator for that. That's 576. Oops. And I'm going to leave everything else alone for now. 4 cubed, 4 times 4 times 4 is 64. And 576 divided by 64 is 9. And that goes on top, right? It's 9 over 1. All right. Again, we're just going to subtract the exponents here. 16 minus 12, right? And then y to the power 2 minus 3. So this is 9 times x to the 4. 16 minus 12 is 4. And 2 minus 3 is negative 1. So 9x to the 4th, y to the negative 1. But remember, you're not allowed to have negative exponents, so just bring it downstairs. This is 9x to the 4th divided by y to the 1. Or just 9x to the 4th divided by y. Okay, and skipping D, I'm going to do 5e. Here we want to simplify y to the 2n minus 3 times y to the 3n plus 7 squared over y to the 4n plus 1. Okay, so this is definitely a more difficult one, and it's one that you may not have even seen before with these n's here. So what is n? N just represents some number. We don't know what that number is, but it just represents a number. So you're still using the same rules for exponents here, right? So the first factor here is y to the 2n minus 3, and there's not a whole lot we can do with that right now. But notice the second factor is squared. So remember what rule you're using here. You're just using the rule a to the m to the n is a to the m times n, right? So we're just going to multiply this exponent here by this 2. So this is going to be y to the power 2 times 3n plus 7. And then the denominator is y to the 4n plus 1. Okay, so all I did was use this rule for this factor up here. Okay, now what? Well, we still have y to the 2n minus 3. But notice I can distribute the 2 here. 2 times 3n is 6n. And then 2 times 7 is 14. Okay, so far? Right, so now, how do I multiply these? Well, notice I have the same base, but different exponents. So when you have the same base and different exponents, here you add the exponents, right? So the denominator will be the same, y to the power 4n plus 1. The numerator will be y to what power? So 2n minus 3 plus 6n plus 14. Okay, so this is just 2n plus 6n minus 3 plus 14. Just changing the order here. 2n plus 6n is, I believe, 8n. And then negative 3 plus 14 is 11. Right. And now we're almost done. Right. Now the rule is, and we've used this already, I just didn't write it down, when you're dividing exponential expressions, you subtract the exponents, right? So this is going to be y to the 8n plus 11, right, minus 4n plus 1. And that you can probably do that in your head, right? This is 8n minus 4n plus 11 minus 1. So 8n minus 4n is 4n, and 11 minus 1 is 10. So we get y to the power 4n plus 10. Right. And you can leave it like that. Or you could use the rule backwards, right? You can say this is y to the 4n times y to the 10. I mean, I would accept that as well, but I would just leave it like this. And that's what it says in the answer key. So.